Differential Scanning Calorimetry, or DSC, is a thermoanalytical technique in which the difference between the heat required to increase the temperature of a sample and a reference is measured as a function of temperature. To put it in simple words, let's say you want to know the heat required to change phase of a certain sample. For this, you gotta have obviously the sample and a reference. And then heat is gonna be added at the same rate to both the sample and the reference. So let's say the analysis is complete and then you wanna interpret the results. The outcome is gonna be a graph in which there are two possible outcomes. The first one is a peak pointing upwards, and the second one is another peak, but this one is gonna be pointing downwards. So if the peak is going up, then the sample suffered a exothermic transition. This means the heat flowed out of it, and this could be caused by a crystallization, a curing, or an oxidation. And if the peak is going down, this means that the sample suffered an endothermic transition, which means the heat flowed into the sample. And this could be caused because there was a melting, a vaporizing, or it was a glass transition.
Phase-change materials are substances that have been studied for years due to their ability to capture thermal energy when it's available and store it. The main approach for the study for phase-change materials is to reduce the energy needed in order to change the phase of the material. Phase-change materials can also be classified as organic, inorganic, and eutectics, based on their composition or solid-liquid phase change or solid-solid phase change according to the initial and the final phase. 3D printed was used to create the specimens to be studied. Their dimensions were 2 millimeters by 2 millimeters by 1.5 millimeters. All the parts were printed with 100% infill, which means it's a solid part, with a heated bed at 60 degrees Celsius, a nozzle of 0.4 millimeter diameter, and a printing temperature of 200 degrees Celsius. Then, the specimens were brought in contact with two phase change materials, A44 and A58. The number that is next to the A, it says the temperature in which the phase change material will change phases, in this case at 44 degrees Celsius and 58 degrees Celsius. Afterwards, the mass was monitored after 1 day, 2 days, 3 days, 7 days, 14 days, 28 days, and finally 40 days. Those specimens were scanned using the differential scanning calorimetry using a Zetram STA with the 3D printed specimens at the given times.
Considering the results obtained for the PLA analysis, the conclusions are the following. The first conclusion is that the samples are stable in terms of mass. This is because during the whole process, the mass increased by very little percentage, and by the 28th day, the mass was completely stable and did not increase more. The second conclusion was obtained by using the differential scanning method, and this showed that the PLA improves its crystallinity over time and working at 65 degrees Celsius.